Hello everyone, welcome back. So now let's go through some examples of what we just learned. As a note, you should be trying these on your own. Now yes, I'm going to walk right through this. The solution is in the PowerPoint. You have access to it, but you're not going to learn anything if you just look straight at the solution. So try the problem on your own. After this first slide, I'm going to have a little PSA announcement where I say, go try it. Pause this video and then come back. So remember that. Keep going. Okay, so here is our problem. You see we have this little stake in the ground. It has a hook, and that hook has three forces. Force 3, 1, and 2. Why in the world did they do in that order? I don't know. We see this one's 300 newtons, this one's 600 newtons, and this one's 450 newtons. Now this one gives us an angle, but this one gives us a slope, or a force triangle. If you've never used that before, it's actually extremely helpful. Why is it helpful? Well, it's because cosine theta, sine theta, they're all just ratios. And the ratio is already given to you here, so you don't even have to use trig functions. Okay, so it wants to find the magnitude and the angle of the resultant force. Pretty easy. And also, if I don't tell you what unit to give, just give the same units as in the problem. So if I say magnitude and it's given in newtons, give me newtons. Usually I tell you. If I don't, it's on me. Okay, so how are we going to solve this? First, we're going to solve the issue of getting my head out of the way. 1, resolve the forces into their x and y components. 2, add all those components together. The I components and the j components, or the x components and the y components. Add them all together. Keep those separate though. So all the x components in one section, all the y components in another. And then we're going to find the magnitude and angle using Pythagorean Theorem and inverse tan. Okay, so I pretty much told you exactly how to solve the problem. So, pause, go do the problem, and then come and restart the video. Okay, counting to 3, and let's keep going. So you've probably tried the problem now. Hopefully it went well for you. Usually I give my students about 5 to 10 minutes to do this. So at that point, if you're still struggling, here we go. Let's walk through it. And move myself out of the way. Okay, so we have this force. We need to resolve it into components. Now, how do we do that? There we go. First off, force 1 is super easy. It's going straight up. It has no x component, so it's all y. Just remember that j is usually connected to y, I is usually connected to x. It doesn't have to be, but that's just standard. Okay, so it has no x component. Force 2, you can see that it's going in the negative x direction, so it's going to have an x component, and it's going in the positive y direction. So we can use our cosine and sine function to get that. So for the x component, we're going to use adjacent over hypotenuse, a over h, and so it's going to be cosine of 45 times 450, and it is negative. We say we put the negative sign there because we're not doing cosine of 135. If we were, it would be take care of it for us. But since we're using the minor angle, we have to make sure we add the negative in. And then to get the y component, we're going to do opposite over hypotenuse, which is sine. So it's sine of 45 degrees right here. Okay, and if we plug that in our calculator, we get negative 318.2 and 318.2 for both of the components. And finally, the last one, we use our slope triangle. And you see right here, this is the magic of it. Because you don't have to do any math, it's just already done for you. Now, what's going on here? Well, this is the y component, this is the x component. The 600 probably makes sense to you, because that's the magnitude. It's analogous to what we had before. Same exact thing. We had 450 before, now we have 600. What about this 3/5 and 4/5? Why not 4/3 or 3/4? It's because we're just using cosine of theta. So for that little triangle, 5, 4, 3. We don't know what theta is. So you're like, oh, if only I knew cosine of theta, I could do that, because it's just magnitude times cosine of theta. What is cosine of theta? Well, it's opposite over hypotenuse. So cosine adjacent over hypotenuse. Your professor makes mistakes too. So it's cosine of theta is equal to 3 over 5. And what you see here is you don't have to solve for theta. You already know what cosine of theta is. It's 3/5. So any place you might use cosine of theta, you'll use 3/5 instead. And for the same thing, what is sine? Well, it is opposite over hypotenuse. So sine of theta is going to be equal to 4/5. So once again, anyways, I would have used sine theta. I use 4/5 instead, and I'm done. That's it. Don't have to worry about anything. I love slope triangles for that reason. I might go back and forth between slope triangle and forced triangle. So forgive me if I do that. Okay, so we have all of our components, and now we just add them all together. So we do a little bit of math. You plug into your calculator, being very careful of your negative signs. That's the biggest mistake people make, is they forget a negative sign and they get the problem wrong. So any problem on any quiz, on any homeworks, you have like 5 or 6 attempts, so it's pretty easy to figure out. Let me know that. And always submit your work. I'll give you credit even if you make a mistake on that, but try not to make it. Okay, so here are our 2 components. You can see that it's barely going in the x direction, but it's really pointing up, which makes sense because all 3 vectors were pointing up and only 2 of the vectors were pointing in the positive direction for x. And then we just use Pythagorean Theorem, which is right here. We sum the square of the components, and then we take the square root. And we use our inverse tan function to get the angle. Okay? So, and there you have it. So it's 87.8 degrees, so it's just barely shy of being 90. And we know what its length is. And that is it. This is this problem. You can see how we broke everything into components, how we used our trig functions to solve for all the components, how we used a slope triangle to solve for all the components, and how we used Pythagorean theorem and our inverse tan function to get the magnitude and angle. You're going to do this Pythagorean theorem all the time, so you know how to do it. Okay, I hope this helped you, and I'll see you all next time as we do another example. Bye-bye.